feature, the Match Recognise clause, with data from our Big Data Lite movie application. My name's Keith Laker and I'm a Senior Principal Product Manager for Analytical SQL and part of the Data Warehouse Product Management team. Before we get into the full part of the demo, let's start by looking at the Big Data Lite virtual machine, just in case this is completely new to you. If you've not yet looked at the Big Data Lite VM, then there are links on the Big Data web page that will allow you to download this virtual machine. Within the virtual machine is a sample movie application that lets customers browse our movie catalogue, select films to watch, and then rate those films. All this activity from our application is captured in a log file, and we're going to analyse the data captured in that file. So as you can see on our OTM page, there's a lot of material here that will guide you through the key features for the big data environment and the movie application. If you want to find this page, again, it's either linked on our big data site, or you can just search for our Big Data Lite VM, and the first link that Google brings back will take you to this page. As I said, there is information here on our Oracle Movieplex application, links to our hands-on labs, and our websites and white papers, etc. If you want more information about our Database 12c pattern matching feature, again, you can search for our Analytical SQL page on OTN, and the first link that comes back is here, will take you to our OTN homepage. On this page, you'll find general information about pattern matching, as you can see here, along with all the other SQL analytical features, and there's links to various white papers, Apple iBooks if you have an iPad or Apple Mavericks operating system, along with online tutorials. As we said, we've already started our virtual machine. We've pre-installed an Oracle database called ORCL into this environment. That is up and running. I have a listener, and that is already started and has connections to ORCL. So my environment is ready for me to begin this demonstration. You'll notice that we've pre-installed SQL Developer for you, and I already have that running in my environment here. For the purposes of this demonstration, we're going to use our pattern matching demo user, which is called PM user. But before we get into that, let's have a look at the log file that we're going to use during this demo that contains all of our information. So all the data we need is stored in our movie application log file. That is in the directory Home Oracle App Log. The file name is movieapp_30months.log, and this contains all of the click events that are generated by our movie app. If we view the file at the command line here, you can see that we have a fairly standard JSON-like file structure. We have a customer ID, the movie ID, assuming that the customer actually viewed a specific movie, and the associated genre for that movie. There's the timestamp for each click event, and there's a flag to indicate if the film that was being viewed was recommended or not. The last field tells us about the type of activity for this event. Now, the movie demo application schema contains a table with the descriptions of each of these activities. For example, activity 8 is a logon event, activity 9 is a logout event, activity 7 is a search event, and activity 5 is a browse event. If we go back into SQL Plus, we can see this table here, and here's the full list of all of the activities that are captured within our movie log file. Of our log file into our database, and to do that I'm going to create a new directory object. In fact, let me tidy this up a bit so we can see some more information. I've actually created a directory which is here. It's called session file _ dir, and it points to my movie log file. If you want the exact syntax for this command, this is how we did it. So create directory points to my log file and points to the directory for my log file, and then I've granted read and write on that directory to my user, PM user. So that object's now ready for me to use. If we have a look at our log file again, just step back over here, we can see that I can use the comma to indicate the end of each field. So I'm going to try and load is the customer ID, the movie ID, the genre ID, the session date or click event date, the recommended ID, activity ID, and a rating ID. Now I'm going to use the directory to create an external table statement, and to make things easy I'm not going to enforce any deep data cleansing processing as part of my external table. So what I'm going to do is define an external table. So I'm going to create something called raw session data. It's going to have my customer ID, movie ID, genre ID, etc. And as this is going to be an external table, I'm going to use that directory object to build out the information. So I have my session file directory, information about the file, the fact the fields within my file are terminated by a comma, the location of that file is my session file, there's my log file name, reject limit of 1, and that command will then create my external table for me. Having got that set up, the obvious thing to do next is to see exactly what happens if we try and view that. So let's try accessing that external table and see what comes back. So you can see our external tables actually worked, the syntax is correct, and looking at the information here, it's pretty much consistent with what we have in our log file, except obviously now we've chopped it up, although we've still got some data cleansing that we need to do here to remove things like double quotes, curly brackets, colons, etc. But we have a basic external table in place. We can access our movie log file, so we're at stage 1. External table will return us some data. Next step is to do some data cleansing on that, and to do that we're going to use the substring and some case statements. So let's paste in this new block of code. So you can see we're going to substring as we did before, and we're going to look at the activity ID and break that out as required and strip out all of the curly brackets. So let's try executing that. And there it is, there's my cleansed data set. So now we have the basis of a cleansing exercise. Now as we run this, we're obviously pulling data from the external table every single time. So maybe the next step is to load my clickstream dataset into a table. Of course, you could skip this step and just continue to use the external table. If you have the file on a DBFS mount point, for example, then you'll probably find that performance is really good anyway, which means you can leave the data where it is. In this case, I'm actually going to create a table and populate it with my clickstream data. Now, at the same time, I'm going to scrub the data to remove the irrelevant parts of the field. I'm actually going to do some extra processing. I'm going to transform, or more precisely pivot, the activity column so that I can have a separate column for each type of activity marked with a Boolean yes or no to indicate whether that activity has occurred or not. Now, this is really useful once you move on to building data mining models, because attributes such as type of activity typically need to be broken out into separate columns to provide input into the data mining models. So by doing this, we're going to save our data scientists from having to do some extra work. So we're going to use the same approach again, except this time we're actually going to create a table. So let's look at the code for that. And let's scroll up a bit. So we're going to do create table. We're going to call it session data as select, and then we're going to use our substring. So let's just take that out for the moment and let's check that this is going to work. So we have our substrings that we were using before. We have our case statement for taking our activity ID, and then we break or pivot out our activity ID into separate columns. And if the activity ID is triggered, then we'll get a yes. If it's not, then we'll keep it with no. So this is going to give us a much wider data set. So let's try running this data set now. And here you go. So customer ID, movie ID, session date, etc. All the way across here, we have pivoted out our activity IDs, and you can see straight away a lot of yeses for logins, which is very good. We picked up a logout event there. We've picked up a list or search event list here, searching here, customer browsing, and so on. So this is a nice additional transformation that we can do as part of our data cleansing process that we can then hand over to our users. Now, we said we were going to do a create table, and I've actually done that in advance. So let's quickly look and see what's in our table. Make sure that it's got exactly the same data that we were expecting. So here's my session data table, and this is now reading directly from a table. So rather than having to go out to the external file, I'm now actually reading directly from my Oracle table. So as you can see, our data set looks good. We're ready to apply our sessionization logic. But firstly, we need to establish the maximum time interval between clicks, whereby we'll consider that a new session has started. Now, for the purposes of this example, I'm going to assume around about 150 seconds or 2 minutes is the maximum interval that I'm going to allow between click events. Beyond that time limit, I'm just going to assume that a new session has started, even if the user's not logged out. And we know that that logout activity is captured by event number 9 in my activity column. We have a data set. We've loaded it in. So now let's actually work on our match recognize clause. And here's the statement that I'm going to use. So I'm selecting data from my table that we've just built, which is session data. And here's the start of my match recognize clause. And in this code, I'm dividing the data up by using the partition by clause, and we're working on the customer ID. Then within that, we're going to sort by session date. Now, as part of the clause, I'm going to compute some measures, and the first one I'm going to compute is the session ID. Now this will be an incremental number within each partition, which is in this case the customer ID, and we'll see that in a minute. I'm also computing the number of events that are occurring within each session. I'm computing the start date and the start time, the end date and end time for each session, and I'm also computing the duration of the session here by using the end time or the last time within my pattern and the first time event within my pattern, and then I'm recording that in minutes. Now, how we define a session so we can create or compute our session ID from our match number is determined by my pattern, where I'm looking for any number of events S, where the event S is going to be the current session date minus the previous session date in minutes, and I want that to be less than 2 minutes. So if between click events, as we're going through our results set, if the session date or the time of the session here is less than 2 minutes than the previous session, then I'm going to include that as part of the same single session. So let's try executing this statement now and see what comes back. So that's now off running, which is always a good sign because it means my syntax, my match recognized clause is correct. And here we can see some of the output. So we have our first user, user 50, has 8 sessions recorded in our log file. User 83 has quite a few sessions logged by the looks of it, but most importantly they've got more than one event recorded in here. Bear in mind that this is just manufactured data for our log file rather than actual live data from users clicking on our movie app. So some of the results might look a little strange, but the important thing is the calculations are running, and you can understand how to use the match recognized clause and the value of the information coming out. So we have our start date, our start time, our end date, end time, and duration. And we've got that, so 1 minute, 0.75 and so on. So you can see there's quite a lot of information that we can get out of here for each of our users. You can see user 83 here has had 50 sessions, and then because we're partitioning by the customer ID, as soon as we get to the next user, 104, you'll see that that match number here where we were computing the session ID resets to 1 again. So that's a starting point for building our match recognize functionality here. That I pivoted the entries in the activity column. So now let's calculate some counts for each of those activities within each session. So here's our complete statement, and in this case I'm actually, rather than using the select star which we've used in the past, so if we go back to our first one, we just said select star. Now I'm just showing you that we can actually pull out individual columns by referencing them with the MR prefix, which as you can see is at the end of my match recognize statement. I'm actually going to use that just to show you a different way of doing this. So again, still taking data from our log file table where we loaded from the external table, and we have now got our counts. So we're using the same information as before. I'll find the lowest activity ID. So again, going back to my table here, that's probably going to be a 1, which is a rate, and the max. and the maximum we have is 11, which is a purchase. But obviously in this case we'll get the max and the min for each session. And then we're going to count for rates, completes, pause, starts, browse, etc. for our pivoted columns, how many of the activities occur. And again, we're looking for or defining a session as where the difference between the session dates is less than or equal to 2 minutes. So let's run that and see what comes back. Good sign that the query is running again, so obviously all of my measures and syntax is correct. And again, we have our customer 50, we have 8 sessions, start date, start time, end date, end time, duration, activity ID, last activity ID, and then how many activities they completed. Well, we got one login, we have another login. Down here we have an activity for browse, start a movie, complete a movie, and so on. So we're starting to build up very quickly a large amount of measures related to our sessionization information that's going to be of value to people like our data scientists. And as you can see, by simply adding in things like counts on our pivoted columns, we're getting a lot of information here very quickly using some very, very simple syntax. So now let's make the identification of each specific session a little more sophisticated by considering what the activity ID is. So extending the pattern to search for instances where the start event has occurred, i.e. the user started to watch a film, and the complete event has occurred, i.e. the user's finished watching a film. This creates a conflict with our time calculation, however, that we probably need to look at. So if you start watching a film, then it could be a considerable period of time before you click again to complete the film. So if we want to start and complete events to appear in the same session, then we'll have to extend our time interval from its current 2 minutes to something a little more realistic, say 150 minutes. So let's look at this new code. So I've changed the pattern here, where I'm now going to look for 2 new events, which are F and C. F is where we have a start event occurring. C is where we have a complete event occurring. And again, we're still using the same duration calculation, but rather than 2, I'm now looking for 150. Again, we're going to use the prefix match recognize here and assign that to our column names as a prefix. We're going to list out the columns that we're going to call. We're still partitioning by customer ID and sorting by session date, and everything else is the same. What we should find is that, say, the first rows that we get back, we'll probably lose user 150, and we're probably going to lose a lot of user 83's records. So we should get a completely different result set now. So let's execute that, and the query's off and running. Let's see if we get any results back. And as predicted, first user's dropped off. We've now got user 83, got 1 session, started on 10th of December 2023. They're obviously watching a film until 22:08, duration 104 minutes, and we had the complete flag yes, start flag yes, and so on. So you'll see some of these here. We have, for example, this one, user 693, is more than 150 minutes in total duration. So when we're looking for our match here, Don't forget we're comparing against the previous session as we're going through. So where we bring together a full session, obviously matching multiple entries, the total duration of a session could be more than 150 minutes, which is why you're seeing some numbers here less than 150 and some more. Depends on the type of activity that was going on and the total duration of a session. Now obviously we could fix that in here if we wanted to compare the starting session time. We could use first or min session date here against the current session, so the total duration of the session could be less than 150 minutes if we wanted. So that's a further refinement that we could make to create a different result set. So it's very easy, as you can see here, to add layer upon layer of sophistication to our match recognize sessionization calculations. SQL is the incredible flexibility that it provides to prototype new ideas and the speed at which these changes can be made. For example, if we want to completely change the focal point of our analysis from customers and sessions to, say, movies, then it's relatively easy to change the partition key from customer ID to movie ID, and then we can count the number of events aligned to each movie. And this gives us an overview of activity, maybe the popularity of each movie. So let's quickly take a look at creating that code. So again, we're going to use the same principle of the session date and comparing that, and assume that the difference between events is more than 100 or less than or equal to 150 minutes. And here we've changed the partition key to movie ID from customer ID, and that's really all we have to do. There's nothing else that needs to change apart from up here, where obviously now again we're referencing the column movie ID rather than customer ID. So that simple change, we can now just hit enter on that, and our query is off and running. And then we'll get information back about or focused on the movie ID itself. And from movie ID, maybe we could go and step that up or aggregate that up using other analytical features to take into account the hierarchy of movies around genres, etc. So we can see movie 100, there's been quite a bit of activity around movie 100, lots and lots of rows of data. Some days 10 events, 5 events. So we get some measure here of how often each day a movie is being used, and therefore its popularity. How long people are watching it for. Are they watching it all the way through, as in here, or are they stopping maybe after 34 minutes to go off and do something else, or maybe within 8 minutes and doing something else, or maybe here they've just come in and rated it. So we get a lot of information about the interaction of our users around each movie. And this is sort of the real beauty of SQL as a data discovery language. It's rich, it's sophisticated, and it's an agile language, all the attributes that you need for big data projects. And they allow power users and data scientists to very quickly evolve their analysis, as we've seen here. Now, Oracle's match recognize clause for pattern matching builds on existing SQL principles, so it's relatively simple to learn how to use it. And we have lots of training material on our website that I showed you earlier. If you've used other SQL analytical features, such as the windowing functions, then a lot of the match recognize syntax will be immediately recognizable to you. Well, that's the end of this demonstration. Thanks for taking the time to listen to this quick workshop on SQL pattern matching for big data. For more information about match recognize clause, please follow the links listed on the Analytical SQL homepage that we looked at the beginning of this session.